So this question has been asked in GATE 2014. We have been asked to find the base for which this equation is valid. Now, in order to solve such questions, what you must do is, you must convert each of these numbers to the same base. Now, the question arises is, which base do I convert to, right? Which is that one common base into which, if I convert, the calculations will become easy. Mind you, the number system or the base with which we are most comfortable in performing calculations is the decimal number system, right? With a base of 10. That is the number system we use in our day-to-day life, in our day-to-day calculations. So it is best when you are given such sums where you do not know the base or where you have been asked to find the base, you convert them into the decimal number system first and then carry out the calculations. So see, if this equation has to hold true, that means you are performing a division operation. If you have to perform a division operation, then both these numbers have to be in the same base. So let me assume this common base to be x, right? So I assume let the base be x. So I've assumed the base to be x. Now my base is x, then all these three numbers are now in base x, right? Okay, I'll just write it more clearly. So all these three numbers are now in base x. 13.1 base x. Now what to do? Now as I mentioned, it's best if we convert each of these numbers into the decimal number system. Then our task becomes a lot easier. And how do you convert a number into decimal number system? You take the sum of the positional weights. So here you have, like for an example, to explain this point of sum of positional weights, let's just examine this number 312 closely. Here you find 2 to be your least significant digit. Now this least significant digit will have a positional weight of 0. This 1 will have a positional weight of 1. This 3 will have a positional weight of 2. That means my positional weights will increase from right to left. So it is better, in fact I would say it is best to write the numbers when you're converting from any number system to decimal from right to left. You write the sum term from right to left. So what do I write? I write here 2 into x raised to the power of 0 added with 1 into x raised to the power of 1 added to 3 into x raised to the power of 2. Right? This is how you should write it, from right to left, in order to avoid calculation errors. Same for this. Now anything multiplied by 0 will give me a 0, so this is 0, added with 2 into x raised to the power of 1, which is same as, now see, 3 into x to the power of 0 plus 1 into x to the power of 1. Now see, when you're finding or when you're converting a fractional number, then for the right hand part of the decimal point, you will have to take negative powers. How? Like this. You add it up with 1 into x raised to the power of minus 1. And will, the negative numbers will decrease consecutively. So you get minus 1. In the next position, you get minus 2, minus 3, and so on. So if I simplify this equation, I'll get 3x squared added with x added with 2, right? So I hope my calculations are correct. Divided by 2 into x, answer. There's no sum here. This is same as I have x added with 3 added with 1 divided by x. As a result, I'll get a fractional value. Now see, here I get, so here I've got nothing to do. Now if I simplify this part, I get, let's see, 3x squared plus x plus 2 divided by 2x will give me, now see, if I take the LCM, I'll get x, and yeah, I'll get x here. So x multiplied by x will give me x squared. Here I get 3x, and here I'll get 1, right? This is what I get. Now what I can do is, since I have an x here and I have an x here, I can simply cancel this out, right? And now if I cross multiply, I'll get 3x squared plus x plus 2 equal to 2x squared plus 6x plus 2, right? Now if you solve this further, I'll just erase this part. I hope all of you have noted this part down. Due to lack of space, I have to erase this portion. Now, proceeding with the calculation. Now, what will I get? I'll get x squared. See, 3x squared minus 2x squared will give me x squared. Now, x, when you subtract 6x from x, you get minus 5x. And these two will get cancelled out, right? So I'm left with x squared minus 5x equal to 0. Now if I take x as common, I'm left with x minus 5 equal to 0. Now from the zero product rule of a quadratic equation, we get x equal to 0 or x equal to 5. Now a number with 0 base is definitely not possible, because as you can see, if x will be in base 0, then these numbers or these symbols making up these numbers will not be valid, right? So this is rejected and we are left with x equal to 5, which happens to be our answer. So the correct answer for this is x equal to 5. So the base for which this equation holds is x equal to 5. So I hope this has helped you. Thank you.